Did you know that 1 tablespoon of soil contains more organisms than there are humans on Earth? A surprising fact, isn't it? Let's dive into the world beneath our feet. A world often overlooked yet teeming with life and brimming with vitality. The soil. This complex ecosystem is home to billions of microorganisms, fungi, bacteria, and other life forms, all playing their part in the grand symphony of life. Soil is the foundation of our food system, supporting the growth of our fruits, vegetables, and grains. It's the silent partner to every farmer and gardener, providing nutrients and water to plants, and offering a medium for roots to anchor themselves. But its role extends far beyond agriculture. Soil is a climate warrior. It stores carbon, helping to mitigate climate change by reducing the amount of carbon dioxide in our atmosphere. When we talk about carbon sequestration, we're talking about soil. It's a natural climate solution, right beneath our feet. Soil is also a water manager, absorbing rainwater, reducing runoff, and preventing floods. It filters our water, removing impurities and making it safe for us and for the environment. It's a natural water treatment plant working 24/7 to keep our water clean and safe. Soil is a biodiversity hotspot. It's home to a quarter of the planet's biodiversity, from the smallest bacteria to the largest earthworm. Each organism plays a role, contributing to the soil's health and fertility. The soil is a living, breathing entity, teeming with life and full of potential. Soil is a history book, holding the stories of past climates and ecosystems, of civilizations risen and fallen. It's a record of our past and a guide to our future. Soil is a resource, a commodity, and a lifeline. It's a part of our culture, our heritage, and our identity. It's a connection to the land, to nature, and to each other. Soil is more than just dirt. It's a world within a world, a microcosm of the planet we call home. It's a source of life, a source of sustenance, and a source of hope. The soil beneath our feet is a silent hero, working tirelessly to support life on Earth. It's time we gave it the recognition it deserves. Soil is indeed the unsung hero of our ecosystem. To understand this unsung hero, we delve into the process of soil testing. Soil testing, much like a medical checkup, is a preventative measure, a way to ensure that our gardens, farms, and ecosystems are in the best possible health. The first step in this process is sample collection. But this isn't as simple as scooping up a handful of dirt. In fact, where, when, and how you collect your soil sample can significantly impact the results of your test. Think of your garden or field as a patient. Just like a doctor wouldn't take a blood sample from a single spot, we shouldn't take a soil sample from just one location. Instead, we should collect samples from several different spots, combining them to get a representative sample. The areas to avoid are those near roads, buildings, or places where chemicals might have been spilled. We're looking to capture a snapshot of the average soil health, not the outliers. The depth of the soil sample is equally important. For gardens and lawns, a depth of about 6 inches is usually sufficient. For larger agricultural fields, a depth of about 12 inches might be more appropriate. The depth is crucial because it influences which nutrients and organisms we're testing for. When it comes to tools, a soil probe, auger, or even a simple garden trowel can get the job done. Just make sure to clean your tools before each use to prevent contamination. We want to test the soil, not the residues from your last gardening project. After collecting the sample, it's important to dry it out naturally. Avoid using heat as it can alter the chemical composition of the soil. Once it's dry, we're ready to send it off to the laboratory, or if you're doing it at home, to start the testing process. Soil testing might seem like a daunting task, but it's crucial to understanding the health of our soil. It gives us the knowledge to make informed decisions about how to care for our soil, which in turn supports the health of our plants, our food, and ultimately, our planet. With our samples collected, it's time to reveal the secrets they hold. Analysis, the next step, is where we decode the language of the soil. The soil speaks to us through its physical and chemical properties, and our task is to understand what it's saying. You see, soil is much more than just dirt. It's a complex ecosystem bustling with life and brimming with information. So let's dive into the methods we use to decipher this information. The first method is pH testing. This simple test reveals the acidity or alkalinity of the soil, which influences nutrient availability and microbial activity. Soils can range from highly acidic, with a pH of 3, to highly alkaline, with a pH of 9. Most plants prefer a slightly acidic to neutral pH, somewhere between 6 and 7. However, some plants, like blueberries and azaleas, thrive in more acidic soils. The next method is nutrient profiling. This comprehensive analysis measures the levels of macro and micronutrients in the soil. Macronutrients include nitrogen, phosphorus, and potassium, the three big ones often referred to as NPK. These are the nutrients plants need in large amounts. Micronutrients, on the other hand, are needed in smaller quantities but are equally important. These include elements like iron, zinc, and copper. Another important part of soil analysis is testing for organic matter content. Organic matter improves soil structure, holds water and nutrients, and supports beneficial soil organisms. It's like the soil's superfood. Lastly, we look at soil texture. This is determined by the proportions of sand, silt, and clay in the soil. Different textures have different drainage and nutrient-holding capabilities, which can significantly impact plant growth. By conducting these tests, we can paint a detailed picture of the soil's health and suitability for different plants. It's like getting a health checkup, but for your garden or farm. Soil analysis gives us the tools to make informed decisions about what to plant and how to care for our soil, ensuring it's in top shape to support plant life. The analysis is complete, but what does it all mean? Interpreting the results is like translating an ancient language. It tells us stories of the soil. Just as an archaeologist deciphers ancient texts, we also need to decode the results of our soil test. Each result carries a message, a story about the health of our soil. Let's delve into the art of interpretation. When you receive the results of your soil test, you'll find information on nutrient levels, pH, and organic matter content. These elements hold the secrets to your soil's fertility and potential productivity. First off, nutrient levels. This refers to the concentration of essential elements like nitrogen, phosphorus, and potassium. High levels of these nutrients mean your soil is fertile, ready to support plant growth. On the other hand, low levels indicate a need for fertilization. But remember, it's not just about adding nutrients. The key is balance. Too much of any nutrient can be as harmful as too little. Next, we have the pH level. The pH scale ranges from 0 to 14, with 7 being neutral. Most plants prefer a slightly acidic to neutral soil, around 6 to 7 on the pH scale. If your soil is too acidic or alkaline, it can limit plant growth and nutrient absorption. Adjusting the pH is a delicate task, so it's best to seek expert advice. The organic matter content is another crucial piece of the puzzle. It's the lifeblood of your soil, providing nutrients, improving water retention, and fostering beneficial microbes. A high percentage of organic matter indicates a healthy, fertile soil. If it's low, adding compost or other organic amendments can work wonders. The results also reveal the soil texture, which affects water retention and root penetration. Sandy soils drain quickly but may not hold enough water for some plants, while clay soils retain water but can become compacted and hard to work with. In interpreting these results, we're not just reading numbers, we're understanding the needs of our soil, the foundation of our gardens and farms. We're learning its strengths, its weaknesses, and how we can nurture it to its full potential. Now that we understand our soil, how can we improve its health? Improving soil health is like taking care of our own health. It's a process that requires attention, patience, and the right tools. One of the most effective techniques is composting. By recycling organic matter like leaves, vegetable peels, and grass clippings, we can create a nutrient-rich compost that enriches the soil and promotes plant growth. Another crucial step in soil improvement is crop rotation. This ancient practice involves changing the type of crop grown in a particular area each season. It can help to break the cycle of pests and diseases and allow the soil to replenish its nutrients. Finally, we have the use of organic amendments. These are substances that you can add to the soil to improve its physical properties. They can increase the soil's ability to hold on to water and nutrients, improve its structure, and enhance its fertility. So remember, healthy soil leads to healthy plants, and in turn, a healthier planet. Soil, it's more than just dirt beneath our feet. It's a living, breathing entity, teeming with microbes, insects, and organic matter. This complex ecosystem plays a pivotal role in sustaining life on Earth, acting as an essential foundation for our food systems and serving as nature's own recycling system. Healthy soil is integral to sustainable agriculture. It nourishes plants, helping them grow strong and resilient, while also acting as a natural filtration system, purifying our water. What's more, it's a vital ally in the fight against climate change, storing carbon and reducing greenhouse gas emissions. But soil health isn't just about what it can do for us, it's about maintaining a balanced, thriving ecosystem that supports a wide range of organisms. It's about preserving biodiversity and, in turn, our own survival. By understanding and improving our soil, we are not just nurturing our gardens, but also stewarding our planet for future generations.